Okay. So yeah, let's go ahead and start from the beginning. So this week we're going to be talking about 2D arrays. A little different than 1D arrays, but we'll get into that. First, I want to go ahead and just review 1D arrays really quickly. So let's do that first. Yeah. So for 1D arrays, so we talked about last week, arrays hold other pieces of data. So for example, if I have like a 1D array of strings, string array equals new string, right? Then if I were to loop through it and I were to run all this code together, what would my output be? What would it print? Do you guys think? Oh, I mean, in this particular example, what would it print? Okay, so yeah, good answers. No? All right, so let's talk about it. So you're right, so sort of. Like when you have an integer array, so like an array of ints, right? Like this. And you make a new array, right? And you don't give it a default value, or you don't give it a value, then the default value is always 0, right? So like you guys were saying. So here, it would usually be 0. But in this case, we're using string arrays. And with a string array, oh, I forgot to change this summon. This is supposed to be a string, so we'll talk about that in a second. But anyway, but yeah, for a string array, the default value is null. So if I were to do this, then it would actually go ahead and have null value as my default. Oh, yeah. That's okay. Right, so for string, it's the default value is null. So if I made a new string array of length 4, and I were to print out all the values of it, it would be null 4 times, right? But here, that's not exactly what I'm doing. So first, yeah, it would be null if I were to just print it out, right? And so you guys were close with the zeros, but instead of zeros, it would be null because it's string. But for if this were an array of integers, it would be 0. But also notice that here, I'm using less than or equal to. And the problem with that is that what happens when I is equal to the array length? When I is equal to the array length, I is equal to array.length, that means I is equal to 4, right? Because the length of it is 4. But what does our array look like? Well, in position 0, we have null, right? Position 1, we have null. Position 2, we have null. And position 3, we have null. There is no position 4, right? Yeah, so it would go out of bounds in this case. So it would just be, this would just give us an error. But if this were just a less than sign, it would print null 4 times. Okay. All right. But let's imagine for a second that I'm just gonna erase all this because I don't have to rewrite the string right there. Yeah. So let's imagine for a second that it gets through this, right? Let's say I change this to less than, so it didn't give me an error. So it prints those. And let's say it runs the rest of this code. Okay. So if I just did this line, would this statement here be true? Would array2 be equal to array? Or like, yeah, would ARR2 be equal to ARR? No, right, yeah, you guys are right. Nice. Okay, I mean, yeah, we know. So why do you guys suppose it would be no? It's okay, we all make mistakes. Yeah, 2 different memory locations, exactly. Perfect, that's right. Yeah, so, right, array2 and array here point to different memory locations because I used the new keyword, which indicates that this is new memory. So this one, even though they have the same values, like this, they both have 4 nulls. This one is one place in memory, so array is one place in memory. And then this one, because I use the new keyword, now array2 points to a different place in memory. It just allocates new space. It doesn't reuse the same one. And this one is different space. But how about this line? After this line, is this true or false? Awesome. Yeah, it's true. Because now, yeah, awesome, guys. Great. Yeah, it's true. Because now they both point to the same place in memory. Because this equal sign assigns array2 to array, which means now array2 points to the same place in memory as array. Now they're the same place in memory. So it doesn't have its own space. It is using the exact same space as array. Which means what? Well, now if I were to, remember, they're all null values, right? So they're all null. So if I were to do array 2 sub 0 equals hello, then what would happen? What would happen to array? And what would happen to array 2? Well, it would go in here, right? It would assign this one in position 0. Instead of being null, now it would be hello. Which means if I were to print out all the elements of array, or if I were to print out all the elements of array 2, in either case, it would print out hello as my first element. Because now, because they pointed to the same place in memory, if I change one, it just changes the memory. It just changes what's in memory. So because both point to the exact same thing in memory, if I change something, both variables have a change. Like array 2 and array, both, if I were to print out both of them, they're going to print out the same thing. So even if I just change array 2, it's equal to array. So if I change array 2, it changes array as well. So now both have in position 0 hello, because both are equal. But if I did it in this case, the first one, it would be different, right? Because this was a different array. Does that make sense to everyone? Anyone confused on that? Nope. Okay. Cool. Yeah. So like that sometimes works. Like if you're comparing, if you're doing some comparison with like +1, then you can do that. But if you want to get every single element in the array, you usually don't want to use the -1. You can do equals and then array.length -1. That's perfectly fine. Like if you do this, less than or equal to array.length -1, that's perfectly fine. But you won't get every element if you just use less than array.length -1. Okay. All right, so let's move on. Okay, so now we're going to start talking about 2D arrays. And the thing about 2D arrays is, let's think about what would happen if instead of using like strings in our array, because we can put anything in an array, right? We can put strings, we can put ints, we can put doubles, doesn't matter. We can use bytes. What if instead we used an array inside of an array? Then we get something called a 2D array. Yeah, so it's just an array that contains arrays. Yeah, today's quiz is just 1D arrays. So this stuff is stuff you'll need to know for the lab, but it's not something you'll need to know for the quiz. Okay, so 2D arrays are an array of arrays. So what does that mean? Well, elements, you can think of them as rows and columns. So first we'll kind of think of them as if like it's just an array of arrays, but then we'll start thinking, okay, rows and columns, because that makes it a little bit easier. But okay, what does this code here do? It makes an array, it makes a 2D array. So it makes an array that's filled with arrays, 2 arrays to be precise. Like it says, okay, we're making an array, right? And we're setting it equal to, this is like 2 things, right? The first one is itself going to be an array somewhere. It doesn't have a defined length yet. And the second one is also going to be some array that doesn't have a defined length yet. But then here, we're setting the 0th element, which was this one, which we didn't have a defined length yet for. We're saying, okay, that one has a length of 2. And then here, we're saying, okay, now this is a new array. This one has a length of 3. So it's just like making new arrays, like inside of the array. So now we have our first element of our array is an array of length 2, and our second one is an array of length 3. So it's kind of like this picture here. Okay. So how do you create an array? So it's a lot like a 1D array. There are a couple ways to do it, right? So you can define it like this or declare it, right? and then you can, on like the next line, you can say, okay, it's an array with it's an array with 3 arrays, each of 4 integers. So that's like saying, okay, I have my array is like this, right? But each of these is an array with 4 integers. So I don't know, I could, right now it's the default value. So it's not, it's just gonna be like 4 zeros, for example, right? And this one also like 4 zeros, 0, 0, and so on, right? You can also declare it like this. And that will also do the same thing because you do it all in line. Or this, what this does though, is it just makes one with 3 rows, and then you can say how many columns later. Or it makes it with 3 elements, but you haven't defined how long each of the arrays are yet inside of your array. And you can also think of it as like rows and columns. So like this, for example, would be an array with, or you can think of it almost like a grid with like 3 rows and 4 columns. Or this one, a grid with 3 rows, 4 columns. And we'll talk about exactly how that would look like in a minute, but you can think of it either way. I think the grids and rows and columns we'll get to, yeah. But you can't do something like this. You can't say new int because we're not defining length, right? And you can't do this either because you still haven't defined what the elements, we're making a new integer, right? We haven't said, okay, how much space do we need? So you can't do either of these. You always have to set, whenever you use the new keyword, you always have to at least set the first value. How many rows you'd have or how many arrays you would have inside of your array. Okay. So yeah, what is a 2D array? I guess we started talking about that, right? But let's talk a little more. So let's talk about this first idea first. This one here that we were talking about a minute ago, right? We have like our array A, right? And it has, if we have it new in 3, 4, right? It makes an array. It makes 3 arrays like in position 0, 1, and 2. And each of those is itself an array. So it's like saying, okay, we have an array of length 3, and every element has its own array of length 4. And then, yeah, so we have like we have an array of 3 arrays. Okay. Or yeah. So then, yeah, that's all this is. You can think of it like that. But another way to think of it, and I think this is how we'll think of it now on, is just like rows and columns. So when you do new int 3, 4, that's 3 rows and 4 columns. So you can think of it like this: row 0, row 1, row 2, column 1, column 2, column 3, and column 0. So this here is our first row, right? And that is whatever is in here. We can think of it like that, where we just think, okay, the very first one, or our 0th row, is our first array, right? So right here. And then we can think, okay, these are the columns within it. So we can think, okay, this is like row 0, and this is column 1, for example. And it matches up exactly. And then we can have this as well. This is like int AR is the new int 3. It just makes, like we were saying on the last slide, this just makes an array of length 3. You can also define it like this, where it's, you're saying, okay, now you're defining what the 0th element is. So saying, okay, row 0 is now equal to 1, 0, 12, negative 1. So what that does is says, all right, our first array, we're going to say gets these values or these values. And you can go one by one and just initialize in this way. And that gives them the values rather than like 0, right? So does this kind of make sense so far? Because I know like 2D is really tricky. So like, is there anything so far that's like kind of been confusing? If so, that's okay. Just let me know so I can try and explain it better. Okay. All right, cool. No questions, then I'll just keep going. But if you guys have questions, I'll like stop and answer them. Okay, so the visualization of a 2D array. So like I was saying, we can think of it as rows and columns. So here, this is a new integer array of 3 rows and 3 columns. So we can think, okay, this is the rows, the first one's rows, and the second one is columns. So if we look at row 0 and row 1 and row 2, right, we can say, okay, A0, 0, well, that's the 0th row and the 0th column. So that would be like, okay, if I were to have my integer array of arrays, it would be like the first array and the first value in that array. Or alternatively, it's just like the very first thing. So 0th row, 0th column. Then you can think of A01 is 0th row, first column, and A02, 0th row, second column. So the first one, the first value is rows, like I said, and the second one's columns. But if instead I were to change this to like 4, then we'd have to add another column here. That'd be like column 4, or column 3, sorry. And it would be like A0, because this is still the 0th row, but now it would be like the third column, and so on. Okay. So you can think of it as rows and then columns. Yeah. So how do we initialize an array? So you can assign it elements after it's been created, or you can assign it when you're creating it. So kind of like just like a regular array. But yeah, let's look at the first one. If I want to change what's in the 0th row and first column, I can do that. I can just set it to something, right? Because there's just in the 0th row and first column, there's just an integer. If array is an array of integer arrays, right? If it's 2D array of integers, basically, then my 0th row, first column, has an integer in it. So I can just redefine what that integer is. I can just set it to 2. So in this case, I would go to row 0, I go to column 1, and I just like delete whatever's there and set it to 2. So we're still just doing assignment, kind of like we did with arrays before. So you can also instead just do something like this, where you just, when you create the array, you just set everything at once. And this is kind of unusual. Like this isn't probably not something you do all that often, but it's good to know that like it's out there, it exists, you can do this. You can just set, okay, in my first row, I have 1, 2, 3. My next one, I have 4, 5, 6, 8. And my last one, I have 7. And as you can see, they're like, not all of them have the same number of columns, right? Different number of columns for each of them, which is okay. You can totally have that. So if you access elements in a 2D array, okay, well, it's kind of like we were doing with assignment, where you just,
I have a
yeah,
question.
go for it.
Can you
Yeah,
just go
what's up?
back to the table you had that? Yeah. Doesn't like wouldn't those empty spaces, would they be filled with zeros or no?
Oh, that's a great question. So in this case, no, they wouldn't be, because we defined this to only be of length 3, and we defined this to only be of length 4, and this one only to be of length 1. So
Mhm.
what that really is like you have your array, right? And then in your like array 0 is an array of length 3.
Mhm.
So like that itself in memory is like this. It just has space 3. Array 1 has space 4. And array 2 just has space 1. So like there isn't extra space allocated for that. No. If we were to define it like int ar is equal to like new int 3, 4, then in this case, yeah, anywhere I didn't define it would have zeros, because I explicitly said I want each of my rows to have 4 columns. But here, because I didn't do that, I just said, okay, this is the length of all of them. It doesn't make the extra space for you.
Okay. And so you wouldn't be able to assign, like, let's say to row 2, column 2, you wouldn't be able to assign anything to there?
Yeah, no, you wouldn't. That's a good question. Right. You can't just do like, oh, array 2 in this case, right? You can't just do array 2, column 2 to be anything, because this doesn't exist in this array.
Okay.
Yeah. Good question. Thanks. So if we want to access elements in a 2D array, then we can just kind of do what we did before. We were assigning something, right? So you just get whatever's in the 0th row and 2nd column. So array 0, 2, this is gonna, in this case, we have to look at our rows. So let me make the table for this one. 1, 2, 3, 4, 5, 6, 8, and then 7, right? So row 0 is this one. Column 2 is this one. So I would get 3. So this assigns num to 3 because it's 0th row, 2nd column. If we use this example. And so yeah, accessing elements is you just give it the row and column index you want. So like where in your table, where in your grid is it? Okay, any questions about anything? Okay. All right, then let's talk about something else. Let's talk about like how we would use dot length. So dot length in a regular array is easy enough, right? It's, I mean, maybe a little confusing at first, but if you have like an array, right, and you want to know how long it is, you just use dot length, right? That just gives you the length of the array. Well, it's a little different with 2D arrays because we think about it, right? Not all of the rows are necessarily the same length. So if we just do array.length, it still gives us the length in this case. It's going to give us how many rows we have. Because remember, we were thinking of it as every row is itself an array, right? So because of how it's stored, because every row is an array, when we do .length, it just tells us how many rows there are. Because like AR is, I don't know, it's, for example, we could have something like this, where each of these, if we did like nuint 3, 4, right, that gives us 3 rows, 4 columns. But also it says, okay, we have 3 arrays, each of those is length 4. So AR itself has 3 elements. So how do we know how many columns we have in each row? Well, we just get that particular row. So if I wanted to know how many columns that that the first row has, or sorry, the 0th row has, then I would do AR sub 0 dot length, because that gets me, this part here gets me my 0th row, and that is itself an array, right? And this would tell me how many columns that row has, because I'm getting that array and it's telling me how long that array is. And because we're thinking of it as rows and columns, this row, the 0th row, has this many columns, dot length columns. So in this case, yeah, we use AR sub x dot length, gives us the length of the array, like the number of columns in a row. So, okay, we can go back to the same example again, and we can look at it again. We can say, okay, 1, 2, 3, 4, 5, 6, 8, and then 7. And we look at AR1 dot length. Well, that's our first row, right? Not the 0th row. This is 0, 1, 2, and 0, 1, 2, 3. We look at array 1, its length is 4. So this would assign length 1 to be 4. If we just got the length of the whole array, that gives us how many rows there are. Well, there's 1, 2, 3 rows. So this would just be 3. Right. So if I use this, like if I put something in here like I do, that'll give me the number of columns in that row. But if I just do AR.length, that gives me the number of rows. So .length is number of rows, and AR sub 1, for example, .length is the number of columns in row 1. Does that kind of make sense? Oh. All right, well, I can ask you a question in chat or just talk, doesn't matter. Okay. So yeah, it gets a little more complicated though, I guess we'll talk about, because now what happens if I want to loop through it, right? Because before we could just loop through a 1D array. If you guys remember, if I want to loop through a 1D array, I can do like int I equals 0, I less than array.length, I plus plus, right? And then I can access all of my elements. I can do something like this. I can do like array I, array at position I, and I can do something with it, right? But now it's not as simple, because now instead of having rows and instead of just having like one array, I have rows and columns. So I have to say, okay, for every row, like for an I equals 0, so I go through all my rows, row by row. So I start here and I go my first row, and I keep going. I say, okay, within that row, give me every column, and then I can just get that element. So let's think about when I equals 0, right? I can say, okay, I want row 0, and I want column 0, and then I want column 1, and then column 2. And then this loop finishes, and so I go back here, and now I is 1. Well, I is equal to my row number. So now rows is 1, and columns is, I entered this loop again, now columns is 0 again. So I get this one, and then this one, and then this one. And then I leave the loop because it's not less than the length anymore, so now I go 2. So yeah, so it gives me, if in this case, let's actually walk through exactly what's going on. So here I have an array, and it's 5. I have 5 rows and 3 columns each. So when I make it, it's like this. 5 rows. That's 5, yeah. Okay, now I starts at 0, and that's my first row, right? Because we're looking at AR.length. That's the number of rows. So we're going to look at how many rows we have. So we're going to loop from, I is going to loop from 0 up to the number of rows, and that's 5. Now I go inside of my inner loop, and j is going to loop from 0 up to 3, which is the number of columns I have. It'll stop at 2 because it's less than. But anyway, I do AR sub I sub j. Well, that's I is my row number, and j is my column number. So it's going to set the element in the position of row, column, to be whatever the row number is plus the column number. In this case, I plus j is 0. So we set this to 0. And then we go to our next column, right? Because we're inside of this inner loop, and this inner loop just does columns. So next we're going to set the 0th row, because I is 0, and now j is 1, right? So when j is 1, now we're going to set this to 1, because this is our 0th row, first column. Then we set this to 2, because it's still our 0th row, and now second column. And then we finish our inner loop. So we go back out to the outer loop. And now we increment our row number. And now we go back through. Now j is 0, and I is 1. So we set this to 1. We set this to 2, and we set this to 3. And we keep going like this. Now we increment I. J goes back to 0 again. And we start our inner loop again. But now we're in the second row. So we would go, well, we would get 2, 3, 4, and it would end up looking like this table here. Because we're going row by row, and for each row, we're getting all of the columns in that. Because we're finding the length of that particular array. So like that particular row, we find the length of it, and then we do something on each of its elements. So ij. Okay, so does looping kind of make sense to everyone? Give me a thumbs up if you're not lost, or if it makes sense. Awesome, cool. Then I'll get them. Okay, so on iterate third array. The original PowerPoint on the previous slide used just a 0 here instead of an I, but I just changed to I because you won't ever run into problems if you just do, in your loop, if you just do like AR sub I. If your outer loop is using I, then you can just always do like AR sub I or whatever variable you're using your outer loop to find the number of columns. Because even if the number of columns is always the same, it doesn't matter, because if you set it to this value, like if all of them have the same length, or even if they don't have the same length, it won't ever give you an error, because even if like it were like 2 rows, or yeah, 2 rows, and each of them was different number of columns. So maybe the first one is 2. Okay, this is a bad drawing. So I'm just gonna say, okay, even if I had, I don't know, 0, 0, and then 0, 0, 0, well, what this does is says, okay, it's the number of columns in that particular row. So in this first case, it might be 2, but in the next one, it might be 3. So that's my suggestion, is just always put like I there. Just don't use a fixed number, because if you just use like I, it'll always work fine. So, okay, right, because otherwise, if you have a different number of columns in each row, like in this case, if we had in the first one, or in the 0th one, we would have 3, and in the first row, we would have 2, and last row we would have 1. So if we use the fixed 0 here, it wouldn't work, because it would just give us 3 each time we go out of bounds second time, because we tried to access ARR sub like 1, 3, and that doesn't exist, right? There's nothing here. So that would give us an error. So that's why I just suggest using I. But anyway, yeah, even if it's not the same number of rows and columns, or if it's the same row, it doesn't have all the same number of columns each row, it doesn't matter. We can still loop through it like this. And in this case, we're still setting the row number plus the column number equal to the, like, whatever's position, row, column, we're still setting that equal to row number plus column number. So in this case, it'd be 0, and 1, and 2, and then still 0. Oh, no, sorry, 1, and then 2, and then 2. Okay. So yeah, that's everything for 2D arrays. So if you guys have any questions about 2D arrays, go ahead and ask, because now I'm going to start talking about the lab, which uses 2D arrays. So that's why we're learning it. Great, just need some water. Okay. So then, okay, let's start talking about the lab then. So yeah, for the lab, we're going to be doing Connect 4. So can everyone kind of see like why we might be using 2D arrays for a game like Connect 4? Like, you can just say yes if you can kind of see why.
Because
Cool.
Connect 4 has like rows and columns, like 2D arrays.
Yeah, exactly. That's right. Yeah, exactly. Right. Perfect. So yeah, that's exactly why we're going to be using 2D arrays. So we're going to create the game. You're going to have to display the game board. Yeah. Keep track of the player's moves and determine the winner. So just those 3 things. So, okay. Let's look at what we're going to have to implement then. So a few main methods. So one is print board, and that's just going to ask you to like print the board. And we kind of already saw what it's like to loop through a 2D array, right? In this case, when we want to print the board, we want to like print every element. If we want to print every element in a 2D array, well, we would have to, just like with a regular array, we have to loop through it and print all its values. Well, we know how to print, we know how to loop through, we know how to print. So yeah. And for initializing, you're just looping through and setting every value to the dash. So we know how to loop, we know how to set things. So, and then the next thing is insert chip. So this one's a little trickier because we get a column that the player wants, and then with that column, you're going to just keep checking the rows and see if you can place it in there. And then you check if winner. So checking if there's a winner, you can just check and see if there's 4 in a row anywhere. Okay. But yeah, good news is that we don't have to worry about like diagonals. You only have to worry about like horizontal or vertical 4 in a row. You don't have to worry about like if it's diagonal 4 in a row, just or down. But we'll talk about that in just a second. Your board is going to be a 2D array of chars. Each space is an X or an O. O for player 2, X for player 1, or a free space, so no one's put anything there yet. Yeah, so the orientation of your board matters, but like really all this thing is like, this is just a lot of words to say when you after you've implemented it, when you actually do your print board, when you actually submit to Zybooks, you have to print it upside down. So you just have to like start at the length and then go back to 0 when you print. So just print it backwards for Zybooks basically. And then that should be fine.
Wait, what do you mean?
Oh yeah, so like Zybooks for whatever reason has when you submit it, it wants your print board method backwards for some reason. So like you can either like flip your board, or I think when you print it, I think you can just fix it by when you do your printing out of the board, you can just print it upside down. I think there's a discussion about it on Slack too, so people were talking about it. But like instead of starting at the first, like the 0th row and going up to the last row, like 0 up to length, like I equals 0, I less than array length. You can just do like I equals array.length minus 1, I greater than or equal to 0. I think that fixes the problem for Zybooks, if I'm not mistaken. But if I am, then it's something to do with flipping the board. Okay. So yeah. The method. Oh yeah. So like I can just, but you'll see all these methods again. It's in the lab document. So it's like it still gives it like a more thorough description there. So you guys will see this on. Yeah, no problem. Okay, so the win condition. So like I said, you don't have to worry about diagonals, but you have to worry about 4 in a row. So horizontal or vertical. But the good thing is there's kind of an easy way to see how this board is kind of laid out, right? Because it's rows and columns. So if I had, I don't know, I'm just gonna make something up. If I had like, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? That's 3 rows, 3 columns. If I had array ij, right? Let's say I is 1 and j is 1. Well, that would be this position right here, right? And this is row 0, that's row 1, that's row 2. That's 0, column 0, column 1, column 2. So if I want to know what's the thing right above it, I just have to subtract 1 from the row number, right? So the row is I, so if I want to see what's right above it, then I can just do I minus 1 j. Well, I minus 1 is just like, this is 0, 1, right? Is the one right above it. And the place we're in right now is 1, 1. So I just have to do I minus 1 j. And that gives me row 0 and column 1. So same column, it just subtract 1 from the row. And that puts you up 1 position. Right? And then if you want to see what's right next to it, you want to see what's right next to it. If I'm in like 5, well, that's still row 1, column 1. And if I want to see the thing that's right to the right of it, that would be same row, right? This is the same row. It's just 1 column over. So that would be 1, 2. So you just need to add 1 to the column number. So you want to see what's to the right of it, you just add 1 to the column. And if you want to see what's right below it, you just add 1 to the row, for example. Or if you want to see what's right above it, subtract 1 from the row. If you want to see what's next to it on the left, you do like subtract 1 from that column. So yeah. But the toughest thing is like for this lab, make sure that you never go out of the bounds of the array, because otherwise your program is just going to stop. It's going to crash, right? Because if there's no data there that it can read, then it will give an error. So just be careful about that, because that can happen if you're not careful. Okay. But yeah, have fun. It's a fun game. Okay, so I'm gonna let you guys work on that until quiz time. But before we start on that, I just want to know, are there any questions on Project 2C?
What exactly are we supposed to submit? Just like a complete, like what are we supposed to submit?
Sure, yeah, so we can look at this, but yeah, as this says here, yeah, you're just gonna like finish the last few methods. Because remember there are 8 methods here and you guys did the first 6. So do the last 2 methods and then like put the whole program together. So basically what you want to have happen is you want it to be able to like do all 9 of these, which you can do using these methods. So basically we just want the main finished. So like implement those last 2 methods and then submit your main. And your main is going to allow the user to put in a number in the menu, and then it does one of those 9 things based on what the user puts in. Does that answer your question?
Thanks.
Okay. And when you put it all together, like as you guys might be able to see, it's like depending on the option they choose, you have to kind of decide which of these methods you're going to have to use.